If everyone could grab a seat, we are going to get our seminar started for this week. So our speaker that is joining us today is Julie Walton. And Julie completed her undergraduate studies here at the University of Calgary in kinesiology with a focus on exercise physiology. And some of the research topics that she explored during her undergrad were the examination of voluntary activation in Paralympic swimmers. And for that project, she worked under Dr. Jared Fletcher and Dr. Brian McIntosh. She's currently doing her Master's of Science here also at the University of Calgary in exercise physiology and health. And some of the topics she's exploring during that degree is stretch, shorten cycle function and muscle tendon unit properties in active early postmenopausal women. And that seems to be the focus of her talk today. And she's completing her master's degree with Dr. Jared Fletcher and Dr. Matt Jordan. Some of the other topics that she's exploring in her master's are comparative effects of resistance, cardiovascular, and combined training on muscular strength, muscle tendon function, and energy cost in postmenopausal women with and without menopausal hormonal therapy. And beyond her graduate school endeavors, she's the owner and CEO of Julie Walton Health, which supports clients through different education, exercise prescription, lifestyle counseling, and culinary support. And she's also had various roles as an exercise physiologist at different organizations here in Alberta. And beyond graduate school, she's interested in managing a multidisciplinary clinic, focusing on key aspects of female health and performance, and hopes to continue research and intertwine those two. So thank you, Julie, and we look forward to your talk.
Thank you. Okay, as we get started, I want you to think about your favorite activities, what you like doing right now, and what you might want to do as you age. And I want you to take that lens as we go through the presentation, because oftentimes we get deep down into the data, and I want us to remember the personal aspect of the research. Today, I'm going to talk about menopause. I'm going to give you a background on how we came to our research question. We're going to talk about muscle and tendon function in active early postmenopausal females. And then I'm going to show you some preliminary data, and we're going to talk about future directions. I came into academia a little late, and I worked with Matt and Jared at the Canadian Sport Institute. And after I worked with athletes and after I worked in more clinical population, I started working, after I had kids, I started working with a lot of peri and postmenopausal females. And a lot of them were really interested in training, really interested in getting fit. And I, working with Jared and Matt, I started getting into the literature again. And I was like, wow, okay, might be an area of interest here. So anyways, that kind of is what led us to coming back to academia. And I'm also just curious by nature. So what we're going to do today is I'm going to talk to you about menopause, and then we're going to relate how that intertwines with muscle and tendon function. So I'm going to draw your attention to the top graph. We have estrogen on the y-axis, and we have days along the x. Now, many of you have probably seen this before or are familiar with it. It is common in the literature as a healthy premenopausal menstruation hormonal cycle. And then and estrogen is in orange and progesterone is in purple. And this is, while it doesn't always look like that for every single person, on average, this is what we see in the literature. An average cycle is usually about 21 to 35 days. If you look down at the bottom here, we still have estrogen on the y-axis, but now it's in years. So this is the menopausal transition. And you'll see the peaks that correspond with the peaks each month. And you'll see how estrogen goes from a cyclical production to a constant low supply. So that's really all I want you to take from those two graphs. And we understand that there are many different hormones going on for females when they're premenopausal, when they're postmenopausal. And we're really going to be focusing on estrogen. Yes, it always takes the stage. It did in premenopausal research and now in postmenopausal research. But Today, we're going to be focusing on estrogen because that's where the majority of the literature is. And I'm sure that with time, it will grow and expand from there. And so here we go. Menopause happens on average about 51 years of age. And it is technically only one day. So after 12 months without a period, you're considered post-menopause. And so before that, you're pre-menopause, and then a day, and then post-menopause. It's quite strange, really. The years leading up to menopause, many people call it perimenopause. And this is often where women start to have symptoms. Okay, a lot of really uncomfortable symptoms come with the menopausal transition, and it varies for each population. There are symptoms such as hot flashes, insomnia, muscle aches and pains, and each woman is very different, and each country is very different. But it's important to know that if you are working with the population, as it can impact their ability to exercise or want to train, even if they are an athlete to begin with. Now, the current treatment options, physicians will prescribe exercise, or not maybe prescribe exercise, but they'll suggest that females exercise. It can help with some of the symptoms, except for hot flashes, which I hear are terribly uncomfortable. And that's where hormone replacement therapy comes in. I'm going to use HRT as when I'm talking about hormone replacement therapy, even though it is now called menopausal, not replacement, menopausal hormone therapy, because you're not replacing the premenopausal therapy. Okay, but it's going to be really hard because I've been writing with HRT for so long. So next presentation, I promise you, MRT, but for right now, HRT. Now, okay, I was talking about the symptoms. We have to talk about some good news, right? Let's see if this works. Okay, so on the right-hand side, we have the Canadian Masters Athletics. There are some postmenopausal females that are doing some amazing things. Okay, so oftentimes, I wanted to put this video up because oftentimes we think postmenopause, we're like, oh, you know, older female. I'm like, I'm pretty sure that a lot of these females could beat me around the track. That is for sure. A third of a female's life is spent in postmenopause. That blew my mind. Okay, and so it is really important to understand how muscles and tendons work. Well, I guess not work, how muscles, what's happening at a muscle tendon level. The symptoms that they experience, the muscle and tendon changes can impact your quality of life and performance. Nationally, there is an increase in female participation, almost meeting that of men. We're seeing 45% participation in sport, females. A third of marathon finishers are midlife females. The biggest growing age group in sport is midlife females, because I think they got the message from everybody in here that exercise is important. Now, something that was really interesting to me is if you look at it, so in 1972 is when Title IX came into play in the United States. So Title IX was a legislation put into place to create equal opportunities for females in sport. And I love sport, so I'm really glad that they, pushed this across. Probably it came down to Canada at some point, impacted us Canadians. So anyways, if you look at that and you calculate it out, the females that benefited from Title IX are now between 50 and 70 years old. They're wanting this information. They want to know how to train, but there's not enough information. Okay, now let's relate it to muscles and tendons, because that's what we're all here to talk about, right? Okay, so with menopause, so after menopause, there's a steep decline in estrogen. And that is associated with muscular strength loss, which can impact quality of life and our ability to perform functional movements. There's been reports that it can impact the Achilles tendon mechanical and morphological properties, specifically Achilles tendon and cross-sectional area, Achilles tendon stiffness. Now, if it's impacting strength and Achilles tendon stiffness, there's the reports are mixed at this point in cross-sectional area and in stiffness. But if Achilles tendon stiffness plays a role in performance, it plays a role in our energy cost of movement, specifically in running. And Achilles tendon cross-sectional area, that's our ability to withstand load. It can impact injury, right? So and these all can impact stretch, shorten, cycle function. So stretch, shorten, cycle function, it is when we have the repetitive stretching and shortening of muscle tendon unit, okay? And it is similar to a lot of the movements that we do regularly, running, jumping, hopping, and walking, okay? So if we're seeing changes in strength as well as Achilles tendon stiffness and cross-sectional area, that may lead to increased rates of injury and impact our ability to move economically. We're not the only ones noticing. In 2024, so this year, in the British Journal of Sports Medicine, there was a call to action for sports scientists to look at females in midlife. Even of the research that has been done is usually on sedentary females, or it's on pathology, so a disease state, okay? There's two interesting points in this article. One was that so they reviewed like 5,000 articles, and 9% of the articles had to do with midlife females. And the research that is there is talking about how important training is and exercise is for midlife females. However, a lot of the results remain inconclusive, and a lot of the results are still mixed. The key areas we're going to be talking about today are Achilles tendon stiffness, stretch, shorten, cycle function, energy cost of running, and Achilles tendon cross-sectional area. And I'm going to go into those a little bit more, just so that we're all on the same page. So why are we studying Achilles tendon stiffness? Achilles tendon stiffness has been associated with a lower energy cost of running, with higher Achilles tendon stiffness is associated with lower energy cost of running. So it can improve our performance. Understanding and optimizing tendon, like our tendon stiffness, can have an impact on injury. Okay, if we're seeing a stronger muscle and if we're having that mismatch between Achilles tendon stiffness and strength, that may lead to injury. And so what Achilles tendon stiffness essentially is, for those of you that aren't in biomechanics, are it's ability to withstand load. So you need more force to deform or to stretch a stiffer tendon. And what is the problem? It's rarely reported in midlife females. Okay, let's talk about Achilles tendon cross-sectional area. Achilles tendon cross-sectional area, it impacts the average stress experienced by the force provided. The Achilles tendon cross-sectional areas it is our ability to withstand load. Okay, and it's been shown in men that increased cross-sectional area is better, but we're seeing in postmenopausal females, especially active postmenopausal females, in combination with hormone replacement therapy, smaller cross-sectional area of the tendon. Stretch, shorten, cycle. Oftentimes people think of the counter movement jump, which is correct. You have the rapid stretching and shortening of the muscle tendon unit to produce more power than you would. You need the stretching and shortening of the tendon to decrease the work of the muscle to produce more force in a movement. So we're talking walking, running, hopping, and jumping. And it's a way that we can evaluate movement in the lab aside from and alongside with running. An energy cost of running, the name says it all. It is the amount of energy it requires to run at a certain speed. Now, why do we care about running economy in postmenopausal females? Well, if you are tired and you need to get in exercise, Okay, running isn't just running to a lot of females. It's okay if they have kids and they are, you know, working full time, they're taking care of their parents. If they can get out for a 30-minute run, that is great. So if we can help them continue to do the things that they like to do, and if we can help them continue to run, then, you know, then they can continue, they can support their health and their longevity. Okay, and there currently is no sex-specific differences in trained males and female, or males between males and females, but we don't know what's happening in postmenopausal females. We don't know if there's a difference. We don't know how Achilles tendon stiffness may impact the energy cost of running. So no one has developed a comprehensive protocol to evaluate muscle tendon unit properties of the Achilles tendon and stretch shorten cycle function in active early postmenopausal women. We developed and tested a protocol to evaluate muscle tendon properties and stretch shorten cycle function in active postmenopausal females. And we examined regional differences across the Achilles tendon length. And we compared Achilles tendon stiffness, energy cost of running, and Achilles tendon cross-sectional area between groups of pre and postmenopausal females. All right, so how did we do this? Let's talk about the fun stuff. So we recruited 12 active premenopausal females, and we're still in the process. We need about 4 more postmenopausal females. And they came in for 2 sessions for approximately 3 hours. We have to start, we're really honestly, we're at ground zero here, because they're in the literature, there are a lot of, there's 2 camps. There's a lot of issues in being able to compare the data because of the methodologies. We're using a lot of different methodologies. And so we wanted to start at ground zero and not have any form of hormonal hormone replacement therapy first, or any form of birth control, any form of hormonal birth control, including IUDs. Now, these are pretty fit women. They have to run at 2.5 meters per second for 10 minutes and achieve steady state. 2 sessions, like I said, and we're getting them there. We have some hockey players, basketball players, runners, and you know, your recreational athlete. Okay, I'm going to give you a brief overview of our study design. Okay, we developed a screening tool because we have a pretty lofty inclusion and exclusion criteria, just especially for this first study. So once they're screened, then they come in to the lab and we do their heart rate, blood pressure, height, and weight. And then we get them set up with ultrasonography. So first I'm going to do I do the Achilles tendon cross-sectional area, and I'll explain that in a minute. And we connect it, secure it to the leg on the muscle and tendon. And then we do some dynamometry to measure muscle strength. We have the 10-minute run to look at running economy, and then on the floor plates for jumping and hopping. We are securing wireless EMG to the soleus tibialis anterior and the lateral gastrocnemius, because the medial gastrocnemius has an ultrasound attached, and one is on the muscle tendon junction, so where the muscles meet the Achilles tendon. And we'll be doing the passive range of motion on the biodex, and then we will do maximal voluntary contractions against a fixed end plate. I joke around and say that we're changing scenes. Olivia's laughing. She helps me a lot in the lab. And so we set up the 3D motion capture. We're using OpenCap. And then we set the participant up to do the 10-minute running economy test. Hold on. So they run for 10 minutes, and we're looking for steady state. And we're defining that as a change in less than 200 mils per minute for a 15-second period within the final 2 minutes of the run. And we're collecting this with the metabolic carts. We're collecting expired oxygen and carbon dioxide. Then we have our next scene change where we set up the cameras again, and we have the participant on a force plate. The entire time they have EMG and ultrasound secured to their lower leg. And now we are collecting ground reaction forces, and they are doing 4 counter movement jumps. We are going to be we do hopping as well in our protocol, but we don't have the data for you today. So, okay. So when we're doing, I want to talk to you a little bit about our protocol for the Achilles tendon cross-sectional area, because this is one of the probably the most reported pieces in the literature for postmenopausal females. And when we were trying to compare the results, it was really difficult because everyone used a different method. And so we wanted to develop a method that was that we could evaluate the reliability, and we could select to use this in previous research or in later research. So first, we measure from the attachment at the calcaneus to the proximal region at the muscle-tendon junction, and I confirm that with ultrasound. And then, then I mark on the leg. We have the most distal region, and then we have 25, 50, 75, and proximal. And we mark each measure so that we have it exactly the same each time. And then I do 2 scans at each region. From the scans, we take 5 measurements each, and we have a mean for each region for each participant and each session. Achilles tendon stiffness, we're looking at, so we have on the y-axis, we have Achilles tendon force and Achilles tendon elongation, so how much the tendon is stretching the force is from the maximal voluntary contractions. Same with the tendon elongation. And we take the slope of the force elongation curve from 50 to 75%. And here is the calculation. And that's how we're calculating Achilles tendon stiffness. Okay, let's talk about some results. When evaluating Achilles tendon stiffness, it was significantly higher in the premenopausal group compared to the postmenopausal group. And the difference in energy cost of running between trained pre- and postmenopausal females was not significantly different. One thing, I did it right before I came, and at 0.051 for the p-value and the difference between strength between groups at this time. So for strength differences were not significant. And now if we're looking at the relationship between maximal, force and stiffness, so we have stiffness along the x-axis, and we're looking at the relationship between force and stiffness and running economy and stiffness, and there was no significant relationship there. And why do we care about this? Why did we look at this? Well, what is interesting is, what is happening when you have so if we're looking at force here and we're looking at stiffness, if we have a more compliant tendon down here and they're really, really strong, that may be a consideration for injury. We don't know. We have a lot of data to analyze, and we need to look at this a little bit further, but those are the things that we're thinking about right now. Okay. Now let's talk about there are significant regional differences across the Achilles tendon length. So here we have, supposed to say distal 25, 50, 75, and 100. So there was a significance between the regions. And I put this in here just so that you can kind of get a visualization of the average pre- and postmenopausal cross-sectional area. So this is comparing the resting lengths between pre and post cross-sectional area, and they were pretty close. Okay, now we're going to look at the retest reliability of the Achilles tendon cross-sectional area regional measures. So for all measures across the length, there was good to excellent retest reliability, with the lowest being at the 50%, which makes sense because that one is harder to analyze, I'm telling you. And then the distal Achilles tendon had excellent retest reliability at 0.94. Now, if we look at the Bland, so we have Bland-Altman plots. Up here we have the for the distal cross-sectional area, and down here is for the 50% length across the Achilles tendon, the resting Achilles tendon. And so I'll draw your attention. So this is the line of bias, and then we have the limits of agreement they're in the dotted black lines here. So the bias for the distal region was 6.4 with the limits of agreement at 14.1 to 1.3, or minus 14 to 1.3. And the bias was 1.86 for the 50% region with the lines of agreement at 8.5 to 4.8. Now, I'm going to talk about this a little bit further when we go into the into the jumping data. But so even though that the distal had an ICC of 0.94, there was a larger spread compared to the 50% region. So for the retest reliability for running or for energy cost of running, we had an ICC of 0.83. That was in our preliminary data. We have finished data analysis on that, and it is still excellent at 0.8. Achilles tendon stiffness had good retest reliability with an ICC of 0.75 and maximal force at 0.68. Now this is the Bland-Altman plot for the energy cost of running. Again, we have the limits of agreement here and the bias line here. Okay, for jump height, so for all counter movement measures, the retest reliability were excellent. I redid jump height to include all of the data this morning. And that one in our preliminary data was quite a bit lower. But now that we've analyzed the rest of the data, the ICC did go up for jump height. Oh, whoops. And so this is the reason that we care about this. We want to look at, so if you look at peak power, so it has an excellent ICC value. But if you look at the difference in the values for the limits of agreement or for the LOA, it is quite large, right? And so that might be a test that I don't select in this population to use in future research, depending on our question. Okay. And I mean, we still need to analyze more data, but as of this point, I probably wouldn't select that test, where jump height I would for sure. Discussion. Okay, now what does this all mean? A lot of Bland-Altman plots, and so we're starting to see mechanical property differences, but not in function in between early pre and post menopausal trained females. Now, regardless of the small sample size, we are seeing significant differences between Achilles tendon stiffness between groups, as well as a significantly different Achilles tendon cross-sectional area across the length of the Achilles tendon. So we're seeing regional differences that are significant. And why is that important? Well, often Achilles tendon cross-sectional area is reported in the literature, usually at, say, 6 centimeters. And now I'm going to bring you back to, okay, yeah, here. So if you look at our 50% across the resting length, if you are reading literature in this area, yeah, okay, it's about around 60, between 40 and 60 usually, but often closer to the proximal is not reported. And that would greatly change if you take the mean of right across the Achilles tendon, that would be a lot different. And as well in runners, I was looking at the literature because I was going crazy because I was like, why is my data different than what is in the literature? And then I'm Jared and I are looking at different papers, and with running, we've seen data that there is the larger cross-sectional area in the distal region, which makes sense. And we're seeing the same thing in our research as well. Okay, but overall, we really need to analyze more data. And we're going to continue our work by looking at muscle and tendon mechanics and energetics across all of the locomotion in our study. So now, what is the significance of our work? Well, hopefully it is to improve our understanding of the effects of menopause on muscle and tendon function in active females. We want to support future research with reliable methods for this population to encourage future work in post-menopausal females. And our study is not without limitations. It is a cross-sectional study, so we cannot draw any cause and effect. And it is really difficult to isolate one specific hormone. You can't do that in a human population. So this might be something that would be really interesting to look at in an animal model. There has been some work done in that area, but I think that it would be very interesting. Also, we use the term postmenopause, and we defined 12 months without menses, and that is how we determined postmenopause. In larger study, or specifically if we're looking at groups, say hormone replacement therapy users and non, it would be beneficial to use blood or urine to confirm hormone levels. So I just want to thank my supervisors, Dr. Fletcher and Dr. Jordan, and my committee, Dr. Tish Doyle-Baker and Kathy Panson, as well as my colleagues. So thank you very much.
All right. Thank you for the presentation. It was great. Regarding the large effect size that you saw in the stiffness of the AT, and I think in the beginning you explained as sort of a basis of the research as the increase in stiffness in the AT would increase the performance.
Oh, yeah.
Versus you didn't see any difference. Do you have any explanation for that?
Oh, you mean there's no increase in running economy right now? Yeah, so that is a really good question. We would expect there to be in young, in so many different populations, you would expect to see an increase or an improvement, in the energy cost of running. And we haven't finished our data analysis. We still have quite a bit to go. And then we'll be able to probably, look at that a little bit further as to what's going on. But yeah, I don't know yet because we haven't gotten through all of the data analysis yet. So I'll get back to you on that because I'm really curious myself because and almost, I think every population, like even in adolescence, it's been seen. So, yeah.
So you would expect if you analyze the mocap data, for example, further, you would see some differences over there that will be like, I'm trying to think like why that could happen. Like,
you mean in the energy cost of running? So in the like why we're not seeing a relationship there? Yeah. I mean I know I'm not supposed to say that's a really good question, but it is. Jared's laughing at me because I'm like, I'm not allowed to say that. But it is because we've been talking about that too. We're like, I don't understand. So we don't know yet. Yeah, we don't know.
And about the cost of running, some of the participants seem to have pretty high cost of running.
High? Or like you mean they had a really high cost of running?
I'm assuming it's joule per kilogram per meter.
Yep.
They were around 4.5, 4.8.
Yeah. I mean, they're
versus a average runner would be 2.5.
3.5 would be really, really fat, like really, really good runner. Yeah. Yeah, I wouldn't, I was, yeah, even when I was seeing some that were dropping below or like around the 3, I was like, Jared, is this right? Because yeah, no, they, I would expect them, I would expect the population to be around that, above 4 in their energy cost of running.
Is that because of their running form, or is that because of their weight?
No, that would be probably average for that population for energy cost of running. So in like an elite runner would be like lower 3s. Maybe not. I'll double check with Jared, but but yeah, like even when I saw 3.29, I went back and double checked it because I was pretty low. Yeah. Yeah. So they were typical. That I would say that they were pretty average running economy for the population. Yeah. Mm-hmm.
It's important to note that it's gross energy cost, not net energy cost as well. So that's where that 3.5 comes in. 3.5 would be phenomenal.
Mm-hmm.
Especially for
yeah. Mm-hmm.
Colin and then
Okay, thanks for the talk. I was just super curious about where you think those differences in those kind of stiffness are coming from, because there was no correlation you showed with strength.
Yeah, so I just analyzed the data like right before I got here, and it was so I've maybe done about maybe half now, and it has changed. So the p-value is 0.051. I was like, yeah, so that's where we're at right now, but we still have more data to analyze. But yeah, we would expect there to be a relationship, but
so could it be like,
I think that other factors
from the lack of estrogen that's causing this stiffness production, or do you think?
Well,
like I would expect it to be correlated with strength, right?
Mm-hmm, yeah, correlated with strength. Yeah, but there's so many different like as in the paper I was talking about, the one of Jared's, is that like there's so many different factors that impact the energy cost of running, and we don't know at this point if it is the hormonal profile or not, but it may be playing a factor. Mm-hmm.
How did you control for age effects?
Oh, okay. Sorry, did I let you finish your question?
No.
Or yeah, okay. Just wanted to jump right on that. Yeah, so that was actually, I'll bring my, I'm glad you asked that because I did not talk about it enough. I guess I could have done it on the screen, but anyway. Okay. Yeah, when we were developing the methods, it was, and the inclusion and exclusion criteria, it was difficult because, you know, with physical activity, with aging, there's going to, you know, we tried to keep it. That's why we used active early postmenopausal females, and I mean, there's going to be an influence of age for sure in a human population, but what we attempted to do to try to minimize that is we used premenopausal females that were closer to 42. So they were 42. I think we had the cutoff at 26. So 26 to 42. So older premenopausal females, and then younger. So we used the active early postmenopause. So they were only 5 to 6 years. We didn't have any that were actually 6 years. So yeah, 5 years post-menopause, just to try and keep that a little bit closer. And then we tried to account for activity level as well, so that they had similar activity levels because a lot of, yeah, there's going to be an element of aging there for sure. But in a human population, that was our attempt to try and keep it closer.
Can I also ask about, so you showed something where you showed basically 0 of basically the day of post-menopause.
Yeah.
And then you did plus or minus 5.
Yeah, yeah, of course.
So I was just wanted to ask, so you showed all these cyclic peaks.
Yeah.
So what did those cyclic peaks, how are they related to the top graph?
So that's okay. This is 1 month. And each month this will happen, and that will happen every month across the years. So I mean, I don't know if it's a perfectly accurate graph. It's not mine. It was Keith Barr's. No. But it is every month you're going to have the peaks. So it corresponds to a month. But that's not.
There are only, say, 8 peaks.
Right. Yeah. No.
I
see that. Maybe they used like an average. I'd have to look into that. But what they were trying to show was that the last 5 years leading up to menopause, that the estrogen and progesterone on average starts to decline. I think that's what they were trying to show. I'm not sure. I'd have to double check. I'm not sure how they if that is like the average per year or if that is an average over a few months. I'm not sure. Yeah.
Okay, I guess I have not quite a question, but maybe it's a comment.
Yeah.
It sounds interesting to me of what happens in this basically acute period.
Yeah.
And I guess for me, acute before and after.
Yeah.
And so I asked a similar question to Matt in another talk, which is I always want to get rid of groups if I can.
Yeah.
So post-menopause kind of bugs me a little bit because it's a clinical term.
Right.
But then it is throwing away what I would say is super interesting data.
Yeah.
Now, of course, nobody knows, or maybe people do know, but basically 12 months before you hit post-menopause, I'm assuming people don't exactly know that that's their last period.
Exactly. Yeah.
But maybe they have an idea because things are feeling weird.
Yeah.
Maybe
it's lighter. Yeah.
And the cycle duration. So it just seems like there's a lot of helpful information in that, you could say, last period coming before and then, right after.
Yeah.
And also, I mean, clearly we see these hormonal changes. And so I'm just wondering, is there a way of making the data collection less discrete? There's this group and this group.
Yeah.
And it's even conceivable some of your premenopausal are just in that magic year, or even you could say a couple of years of higher variability.
Yeah.
So is there a way of getting more continuous information, basically, that would kind of feed this kind of study?
So that you can evaluate that perimenopause phase. Is that what you mean?
Yes, and also, so the problem for me with discrete groups is that you can't do a regression on groups, but you could imagine that Achilles tendon stiffness might be a function of, I don't know, FSH,
right?
And that there is a more or less continuous relationship between them, but we would never know from discrete data of two groups. We might get an idea of these things are all high in one group and these things are all low in another. But I'm just curious whether there's a way to gain information which would inform continuous relationships.
Yeah, when we were designing it, we were talking about too, like how there's very limited research in that perimenopausal time, because it's, again, remember how when people didn't want to study premenopause because they had it's so tricky because you have to account for cycle length and you have to test. And I think that that's the same for perimenopause. I think people are scared to study it because they don't know how. And I think that that would probably be my best answer, in that I think it is because it's difficult and we don't know how to do it yet. But I think that, like a longitudinal study would be more helpful in looking at that insight, or maybe giving us some insight on that. But I'm not sure yet, but I think that it's very important. But I think that often people are shying away from it because it's difficult. Yeah.
Kind of a follow-up to what kind of already said, but did you control for the concentration of these hormones in your premenopausal group? Because it seems like they're like fluctuating quite a lot and they're pretty inconsistent. And I would assume that the concentration of these hormones might have some effects on your running economy and like maximum force and things like
Sorry,
that.
what do you mean? Because the
Yeah. So were you able to like measure that or control for that in your premenopausal group?
like, did we take a look at like did we track cycles in the premenopausal
Yeah,
group?
and maybe like test them with like all of your premenopausal women were tested the same part of their cycle or with the same like.
No, we did not do that. No.
To your post.
No, we did not do that. No. Yeah, I think somebody else is going to be doing that very soon, though. Yeah. No, we didn't do that. When we were talking, like as a committee, we just wanted to do, because our inclusion and exclusion criteria was already so long, and we're literally at ground zero when we're looking in the postmenopausal phase, that we didn't look at that. We have another individual that's looking at Achilles tendon stiffness across the cycle. So maybe that will inform some of our future work for sure. Yeah.
Thanks for the presentation, Julie. I'll just follow up with our
comment.
Presumably, you know what age they hit menopause.
Yeah.
So you have a continuous variable in terms of your postmenopausal group. You know how many years since menopause they are.
Yeah.
So that's one way.
Yeah. Okay.
Look at the postmenopause group.
Okay.
If you're interested in looking at
that.
For example, you also probably, or maybe you ask age at menarche.
Yeah.
For the premenopausal group, that also gives you an indication of reproductive years.
Oh, that's,
so,
yeah.
I mean, or even age. There are ways to potentially look at that.
That's really good. Okay.
Yeah. And that was just my comment. But my question was for the test reliability. Can you remind me what the purpose of that was? Like,
yeah. So what we were looking at is, when we were looking at the question we wanted to answer, when we were doing our literature review, a lot of the results were mixed, and not just because of how they were studying it, but it was because of the methods they were using to evaluate, and none of them had been investigated in postmenopausal females or in females at all. A lot of sports science research has not been evaluated for the reliability in females.
So the data that you presented, is that only from the postmenopausal group, not the premenopausal group? So the test retest is only for your women who are postmenopausal? Like the data that you showed on the graph on your development, is that just postmenopausal?
So that some of those ones were all females, and then we're going to section them out into pre and post.
Oh, okay.
Yeah.
And then, what's the rationale behind why a postmenopausal woman would have a different reliability?
And that's why we first started, and we put them all together in one group, and then at the end we can tease it out if we want to, but yeah.
But was that part of informing your research objective? Like, is there evidence that women are less reliable jumping when they
more like, so say for instance, like if we're taking an ultrasound, and we're looking at, it's a lot harder to track some of the tendons. So just because of like fat content, and it's just, if I'm being very honest, it is more difficult in some of the measures to evaluate it in a postmenopausal female due to that. So when we're looking at some of the ultrasound data, it is more challenging in a postmenopausal population.
That makes sense.
Yeah.
And then my comment about your muscle power playing off and was just muscle power, it's a really large value. Like you're talking on the order of 1,000. So your error was actually only 1 to 2%, right? You may not want to throw it out completely. And consider, that the error is a function of how large the value is.
Yeah, for sure. Okay. Yeah. No, thank you. That's awesome.
Yeah, we got an online
question.
Go ahead, Robert.
Julie, you said that there were mechanical differences, as in the Achilles tendon was becoming more compliant postmenopausal, but there was no functional difference. And to me, that suggests that the difference is made up by the nervous system. And if you had a more compliant Achilles tendon, I would expect you to get earlier recruitment of more motor units in that step cycle or in that event, in which case that should show up in an average EMG. So if you've got a mechanical difference change, no functional difference change, I would expect to see the EMG from many average step cycles or events to show more EMG, more power earlier on to accommodate that. Have you considered that, or have other people done that?
Yeah, we're that is our next step in our analysis. So yeah, we're excited to see what we get from that. We're going to be able to take our EMG data, our muscle fascicle length change, our tendon elongation, as well as our ground reaction forces from 10 strides or cross hopping. And then we're going to be able to do a cyclical analysis on that, and we'll be able to take a look at the mean across 10 strides or across 10 hops.
Right, okay, so you are thinking that. I'm just wondering whether you say 10 strides, why would you limit to that to get a good average? Would you not try and do, 100 strides, 200 strides? Or do you know that 10 works?
We're basing it off some of the other work that we did in our lab, and I would love to do 100 strides, but I don't. Maybe in future research, but just to be able to have that much data for a master's study, I don't think I would get approval for that. I would love to look at it though.
Yeah. Okay, thanks, Julie.
Thank you very much.
I've got a question about when you're post-menopause. Do those change? Sorry if I missed this at the start, but do the changes in the hormones, does that result in an increased risk of injury as well as performance, or is it just performance related? Injury, yeah. There's definitely seeing an increase in tendinopathy and rupture in some cases, but definitely tendinopathy, yeah, of multiple tendons. And we're also learning from, well, it was from an animal model, and we're also seeing it in some human data, but that the hormones may impact the tendons differently as well. Yeah. So you saw that there was no change in the volume of the Achilles tendon. The cross-sectional area. We still haven't finished everything yet either. Yeah. Okay. Yeah. But it seems that unlikely there is. So yeah, unlikely that there will be. Yeah. What is it about the tendon property then that's changing, that's relating to the change in stiffness that you might be seeing? Okay, say that one more time. So you found a difference in the Achilles tendon stiffness, but not the cross-sectional area. Correct. So what is the anatomical changes then that might be leading to that change in stiffness that you might be able to change in that population? Anatomical changes. Like, is there less collagen or? Oh, I see what you're saying. Okay. Yeah. Why is there less Achilles tendon stiffness? There are a lot of different theories right now, but honestly, we don't know yet. We don't know. There's been a lot of people that have been trying really, really hard to understand that, but I would honestly say that we just don't know at this time. We don't know, especially because we can't specifically say it is estrogen or it is this. We can say the influence of menopause but it is hard to differentiate between like the age piece, the activity piece. So I think that future research will need to look into that a little bit further. Yeah, and hopefully our final data will be able to give us some more insight on that for sure. Yeah.
Okay, nice presentation, Julie. Actually, I thought that you took some anthropometric measures. Yeah. But I'm wondering where you use these, because I'm not sure if I remember yet the units of the cross-sectional area of the tendon and the stiffness and all of that. So was it, or were they normalized to any anthropometric measures?
No, we will normalize to body weights. But as far as the let me think about for like running economy is for body weight, but what else? Sorry?
Like the cross-sectional
area? No, that data is not normalized to body weight yet. No.
Maybe the size of the leg, the length of the leg.
Yeah, we have those measures.
Lots of things.
Yeah.
Normalize with that.
Yeah. And would you out of the out of those, so if we have the shank length, we have foot length, we have, and then obviously we have body weight.
Do you have the circumference of the calf, for example?
No, we
Just
don't.
The size of the muscle somehow.
No, we don't have that. No. Okay, so you think that by using the shank length and body weight could be helpful though for because we were going to do it to body weight, but do you think that the shank would be also?
I'm not familiar with
yeah.
With it. Like,
right. Oh, okay. Fair enough. Yeah.
I would think
yeah.
that you need to normalize.
Mm-hmm. Yeah, no, we plan to normalize to body weight. But that's the first I've heard of that's interesting. I'll have to look into that a little bit more because I haven't seen that done before yet. I've seen it to body weight, but not. Okay. Thank you. That's a really good point. Yeah, thank you.
Yeah, I have one question.
Yeah.
In the stiffness plots, you got the scatter plots.
Yeah.
There's a lot of missing data, like the data on the two ends and the gap. Right?
Yeah.
So what's going on?
Because we wanted to in our data sets, it was just we were trying to analyze enough pre and postmenopausal females.
So because of that, then you don't get this middle split.
Yeah.
I wonder if this goes back to Art's thing is that because you're missing this data,
you're
effectively never going to get a very good relationship.
Yeah.
Actually be able to understand
until we're exactly. Yeah.
And then I guess on Art's question too with the age thing, it's
I
would think that you'd actually want to do the opposite of what you do, rather than like constrain it, just blow it up, and then
right. Just have a little bit of everything.
Two continuous factors.
Yeah. So sorry, what do you mean by that? Like having
people across a huge number of ages.
Oh, I see.
Right?
Yeah.
Changes with age.
Right.
Changes with as a function of sex. Like ultimately, you want some relationship with Achilles tendon stiffness is going to be equal to age and sex.
Right.
Hormone status or whatever.
Yeah.
So by you need to have a huge spread in all those.
Yeah. Right. Okay. So then if we can't change that now, in future work, if we're looking at hormone replacement therapy and non, then how would you do that in that consideration?
In the same way that you could look at people across, you'd still have a similar interaction.
Right. Yeah. So just having like a wider spread. Yeah. Okay. Huh. Okay.
Correlation.
Right.
You're capturing more population.
Okay. I didn't think about that. Okay. Thank you.
Oh. We'll go Walton and then Art.
I'll go ahead.
Okay. First of all, I think I figured out these graphs.
Oh, I'm okay.
I believe they're just artist renditions. They're cartoons, so they're not data. And so that's why I was confused.
Okay.
But
there we go. Maybe that's why they did it in all those fancy colors.
Yes.
Yeah.
Okay, so I'm going to make an entirely unwanted suggestion.
Okay.
Maybe.
I mean, I'm at the very beginning, so I'm always open. I want to learn
for the future.
Yeah.
People hated hearing suggestions for the middle. I take it that the hormones are easy to measure, right? So it's like
no. They fluctuate daily.
Yeah.
You can't use it to inform status.
But it's still, you can get it from urine, right?
In that sense, urine or saliva, depending on.
Oh, okay. Well, so maybe it's not so fun. But
because that was my idea at the beginning, and then I got kiboshed because of that reason. And then
I'm just imagining doing a hormonal assay, I don't know, twice at the peak of LH and at the peak of progesterone or something like that. So it's not something that's going to ruin someone's life, but they have to do it twice in a month, somewhere around the time of your test. And that way you get some continuous information about the hormones. And I don't mean hormones specifically, except that that's what we have before us. So that's why I'm thinking.
Yeah.
But, echoing Bagley, a tendon or a muscle doesn't know about male, female, pre and post menopause. It just knows about its mechanical environment and its biochemical environment.
Yeah.
So that's why I'm kind of keyed on that. Yeah. Because I'm thinking of, from the tenant's point of view, oh geez, life has been a little bit different lately. Yeah. And then it's remodeling based on all of these things. And so if our mental model is something about mechanical environment and something about, say, 3 hormones, then I'd always be seeking, even if my study is not specifically designed to treat these as continuous variables, I'd always be seeking to collect that data because it could inform, you know, the study for 5 years from now or 10 years from now. Yeah. Because just getting a sense of, you know, what the peaks are doing. Yeah. And for taking in, they're looking at Achilles tendon stiffness across, and Jared, maybe correct me if I'm, because it's not my study, but they found a way to, so that it, like you said, because sometimes it's like they're having to come in like 6 different times to take, you know, hormone levels, and I think that you guys are doing like 4. So as soon as they come in once a week after. Or how is Fatima doing it?
I mean, the easy answer is it's not easy to find.
Yeah.
LH or progesterone. You have to do it. I mean, you can do ovulation measurements to try and find peaks of LH and then go forward or backward from there. But every cycle is different between and within females. That even if you think you're going to get the LH on day 14, you're not going to.
Yeah, they never, unfortunately, look like that.
And we'd love to have them donate blood and spit and urine every day to find that peak, but it's not good.
Yeah.
So to build on this kind of idea, if you get a lot of fluctuations day to day in these hormones, I can't imagine that like you can't respond that quickly. So can you not just low pass filter the data like heavily? Because like, really, you cannot respond that quickly to changes in these hormones, right? You're not going to get material properties.
And we were built for it, right?
Yeah. So like there must be some way to process the signal to make it more tangible and useful. But I mean, someone must be doing this there.
The follow-up here. So what happens to the tendon when there are changes in the hormones? Like, is this material properties that change, or I don't know, how does the mechanical properties change?
That's what they're.
Like I know it's collagen. So what happens to the collagen to change?
And that's what we're looking at. We don't know. Like we're looking at, like some people are saying that there is a change in Achilles tendon stiffness, you know, across the cycle, and some people aren't. So it's mixed at this point. Yeah. They haven't really. I don't think they have any definitive data on that.
Well, I think that our study summarizes it really well.
Yeah.
Just in silico and vitro.
Yeah.
So if you flood a tendon or ligament with estrogen, it will get less stiff. And there's lots of the biochemical reactions that show that that's what happens with the effect of estrogen. So I think there is something to be said for estrogen does affect collagen, which then probably affects tendon stiffness, but that's
so quickly. Like so quickly, like you have estrogen, and then if it's during the cycle, so these are very fast changes in the tendon. I don't see collagen changing like the network and
in silico. What happens within hours? Yeah.
Oh, wow.
Yeah. And of course, those concentrations are way higher than physiological concentrations, so it's not. I would suspect it happens within hours or days, but certainly over years.
Yeah.
So I think that's the rationale for where estrogen is typically high all the time, and then where estrogen is not high all the time. That's why we still have those group differences.
Yeah, good point for me to come in, which I wanted to answer and respond to a few of the questions. You know, one of the things that's come up here is, you know, because you always talk about stiffness, you know, force versus elongation, but really what comes up here, and what you could very, very easily do is that you calculate, you know, a stress-strain relationship in elastic modulus, which then will not depend on your cross-sectional area and your force will depend on the stress.
Oh, okay, yeah.
And the, and then you get an indication of the material properties. Of course, it's very easy to say because you don't really know what the force is you estimated, and you don't really know what the cross-sectional area is because you measure at different points.
Exactly.
It's different everywhere, and then when you put force on it, the tendon gets longer, your cross-sectional area will change as well. So
yeah.
But conceptually, at least, rather than only comparing stiffness, I would also compare elastic modulus.
Okay.
Use the same
yeah.
forces that you have, use the cross-sectional area, and see, and maybe that might actually give you a better value because.
Okay.
You were asking about, the tendon doesn't get thicker or thinner, it might get longer or shorter.
Yeah.
You don't know that, but let's say it stays the same length and has the same cross-sectional area. If then it becomes more compliant or more stiff,
yeah,
it would have to be the material.
Right.
And you would get that at least an estimate of it by calculating stress relationship.
Yeah. Yeah, we could do that.
The other thing that I need to chat about is how do you obtain peak power? You have peak power. How do you measure that?
So we had them on the force plate, and then we used the ground reaction forces to calculate out for watts.
We used the forces acting on the system in a vertical jump.
Yep.
The weight,
yep.
The ground reaction force.
Yeah.
And then you took that instantaneous resultant force and multiplied it by the instantaneous velocity of the center of mass.
Yeah.
And then it peaks at one point, and that's when that.
Yep. Yep.
Now, just so many people talk about peak power.
Yeah.
In vertical jumping, and everybody means something different.
100%. Yeah.
People to define what they actually mean. And
yeah.
You're using it actually in a good way. Most people don't. Where does the Achilles tendon fail?
Oh, where does it usually? I think where it meets the muscle meets the tendon.
So it doesn't fail where it's thinnest, where you have the smallest cross-sectional area, because so that would be the proximal end, and I think that was where it's actually has the biggest cross-sectional area.
So it was thickest at the distal end, and then but we are seeing it's thickening at where the muscle beats the tendon as well.
So is it actually the tendon that fails, or is it the insertion that fails?
I'm not sure. Yeah, I don't know. Yeah.
Insertion. So it doesn't fail at the thinnest point, which you think.
Not from my understanding, but.
We talk a lot about athletes.
Mm-hmm.
Masters athletes. Are there restrictions in female athletes about using sex hormones?
There is not that I'm aware of, but I don't know. I don't actually.
So in men there is. Men
is there?
Testosterone.
Yeah.
As a masters athlete, you get
that's interesting. I never even thought of that.
Yeah.
I don't know.
Yeah. But so you're not allowed to take too much testosterone, otherwise you get testosterone.
Yeah, which makes
So I was wondering if women, estrogen replacement, is that actually tested? And is there a limit that then we can
I don't know. I have no idea. Yeah, that is. Yeah, I was like, because I mean, especially in the Chitty and Barr article. The results of using hormone replacement therapy on muscle and bone are.
If you go to the FIFA, LAF sanctioned like a world championships, or a Canadian championships, you get tested.
Okay.
Men tested. I'm not sure about women actually.
I want.
Anyway.
Now, good. He's on it. I was like, I want to know right now.
I want to get back to what Lee said, about women in Arkansas. Do you check if these women had children and how many children they had and when they had their last child? Could that potentially influence the physiology?
We didn't ask on the questionnaire. No, we didn't. No. We didn't ask.
The only reason I'm saying that is there seems to be this very
weird
correlation of people who have children late, higher than 40, they seem to, on average, get older than women who don't have children or have them early on. Huh. And I always thought that was interesting. Yeah. I'm not sure if that's the physiology or if it's like the social contact or anyway.
No, I did. I don't. We might have asked if they did have kids, but probably not when or the age in the. Yeah. And I don't think we did.
So, you know, we talked about Achilles tendon stiffness and running economy.
Yeah.
Is your underlying hypothesis that Achilles tendon stiffness is a factor that improves or not your running economy?
I would expect that if you know, a higher Achilles tendon stiffness to lower their running economy, but at this time we haven't seen it in the data yet. It's definitely not all complete, but that is what I would expect. But there's so many different, there's so many factors that contribute to. I don't think it would be like, I think that there will be multiple factors that will influence running economy. That is what I think will be the case. But I thought that I would hypothesize that a higher Achilles tendon stiffness would contribute to a lower energy cost of running.
And since I'm in biomechanics, I'm allowed to ask this question, otherwise I would really be embarrassed. How do you measure the economy of running?
We're measuring it joules per.
But what do you measure?
Oh, with metabolic heart. With the metabolic heart?
So you measure oxygen?
Yeah, oxygen and carbon dioxide, inspired oxygen and carbon dioxide. Yeah.
Kilogram,
yeah.
Milliliters per kilogram per
minute.
Yes,
yes.
And when you do that, you account for the fact that some women might have 15% body fat and others might have 25 and others might have 30.
We didn't. I know in some of Jared's earlier work, he looked at that for body composition, and that can influence running economy, but we didn't in this study. No.
I would think so. You know, you have more fat, you add more weight, but it's really not useful weight in that sense. So.
Yeah, exactly. Yeah, we did it to body weight, but we don't have it. We didn't do the body composition. No. Yeah. Yeah. Thank you.
Do you have any?
If I remember correctly, so you excluded the female that had hormone replacement therapy.
Yes. Yeah.
What about including?
That's the next step. That's our next study. Yeah. Yeah. That's our next study. That's what I originally wanted to do. But because we couldn't use, the methods had not been evaluated for how reliable they were in a female population. And so we thought we would do that first and then take a look because there were so many mixed results in the data on all of the different outcome variables we were looking at, that we wanted to like ground zero, step one, take a look, no hormones, controlling for activity level, and then look at the difference between hormone replacement and non. Yeah, that is the goal.
Any final questions?
Very quick, you mentioned animal studies.
Yes.
So what do we know about animal studies and tendon stiffness with and without ovarectomy, or another model of
like an ovarectomy rats?
Yeah.
Well, yes, yeah. I'm actually finishing the proposal tomorrow. No, but in ovarectomy rats, we are seeing for sure in muscle that if you remove, so say you remove the ovaries, and then if you add estrogen, so then you see a decrease in strength. And then you add it back in, you see an improvement in strength. And then there have also muscle. And then as far as tendons, it's a little bit mixed. So I have to kind of dive through that a little bit more. Yeah, because I actually found one the other day that kind of went against what the other research had said. So I don't feel confident in saying anything as of yet, but they're definitely seeing an influence for sure. That's all I can say about that. Yeah.
And is it systemic in all tendons?
So, the the literature at this point is informing us. It came from an animal study, but that estrogen is influencing tendons differently. So, like for instance, the patellar tendon and the Achilles tendon. That's why another reason why some of the methods are mixed, because they're comparing an Achilles tendon to a patellar tendon. And so that's why we wanted to, like, again, step one, look just at the Achilles tendon and then move along from there. But, and then also, so not intramuscular. So it's systemic hormones, not intramuscular. Yeah, it's definitely, it doesn't have any correlation with intramuscular. It's all systemic, yeah.
Sorry, just, do you know anything about extreme obesity and how that might affect hormone levels?
Well, I can't speak to the hormone levels specifically, but I can speak to tendon stiffness, and I can speak to the like menopausal symptoms. Definitely makes menopausal symptoms worse, and it does increase tendon stiffness, but not in a performance measure. You know how, well, of course, look who I'm talking to. But when you're looking at, you know, with a compliant tendon and a stiff tendon, you know, while we want a stiffer tendon, maybe in an athletic population, too stiff is not beneficial, and they're seeing that in obesity. But that was one study.
Do you know anything about hormone levels in women that are extremely obese? I'm just curious, because when we have these very fat rats,
yeah.
It almost seems in the musculoskeletal system that we look at, it almost looks like they age faster. You know, they get osteoarthritis, they get this, they get that, they get diabetes, you know, and it almost seems very high body fat percentage seems to accelerate what you normally would associate with aging. So I was wondering if that might have to do with changes in those hormones.
Well, we know that adipose tissue produces estrogen, and particularly in younger women, you won't menstruate if you don't have adequate adipose tissue either. So there's something going on there, but I have no idea how that would influence the aging process.
So many questions. This is what keeps me up at night. I'm telling you. I'm like, oh.
Well, thank Julie again.
Thank you.